And we are back, and so let's go ahead and get started and start to play and enjoy and start to utilize Mathematica as our tool for this semester for how to deal with big data sets and solve engineering problems and get really, really fun. So Mathematica is pretty, again, it's very unique in terms of what it has to offer. And again, for any coding tool, the most important thing is that you're able to master it, you're able to solve the problem efficiently, effectively, and it doesn't take too much time to do it. So again, there are some problems where Mathematica will be the solution, there are some problems when MATLAB will be the solution, so we just have to figure out what is best for us. So on this toolbar here, there's lots of kind of cool figures. So whenever you start Mathematica, make sure you quit your kernel. So Mathematica is a RAM-intensive program, so we really want to make sure that everything's clear, there's no variables defined. We'll get it all in a second. Additionally, you may be used to, in Mathematica, or actually MATLAB, to kind of writing your script and then evaluating it all at once. Mathematica is more of a line-by-line feature, but you can evaluate your notebook completely if you choose to do so. And there's some formatting options and some ways you could kind of change your screen environment and look at things and do different style sheets. But anyways, this is just our basic kind of starting point, and we'll get into all this in a second. The most important feature on this toolbar is your help function. So when you need help in Mathematica, or when you're trying to figure out what functions may look like, hopefully this doesn't crash. This is on my other computer. This is where you kind of type. So if I want to find out how to take a derivative, I can type it up, and voila, there's a function, or it already kind of tells me how to do that, and there's tutorials, and we'll start to get into these much, much more extensively. But my biggest tip in Mathematica is there is a very active user base, as we've seen in our Mathematica demonstrations. There's a very extensive help menu, guidelines, gives you examples, it teaches you how to use syntax, which is essentially the format in which these functions are read into. So Mathematica is very unique in that it's not like C++ coding. A lot of these functions are pre-built in, and then we're going to code around these pre-built-in functions. So the nice part is once you get a hang of it, and once you kind of know what are the key functions, it's easy to kind of then develop your own functions and program and code. But there is a little bit of a steep learning curve initially because you have to go and search out those functions, search out those things. But my best piece of advice is before you start to try to code it yourself, search through this menu, look at some of these tutorials, guides, functions, look at the examples, the scope, and all these different kind of cool options, as it'll probably let you to the right place. So how did I type this function? So I'm just going to do Control-Alt-1, and I could type my header. So, and I did this by typing, it should probably show my hands. Maybe that'd be useful, but I don't know how to do that. Alt and then 1 simultaneously. So not plus, just Alt, I say Alt and 1 simultaneously. So if I do that, I can type text. So this will not be evaluated simultaneously. What I mean by evaluated is that the way that you kind of evaluate a line of code in Mathematica is you click on it here, or after you're done here, you press Shift and Enter simultaneously, and you see that really didn't do anything. We'll see how that kind of comes to in just a second. This text here is Alt and 4. So this is a very useful, and this is Alt 5. So again, you do, let's say, this is Alt 6, and we could do, what does Alt 8, anyways, let's do Alt 7. So these are the things essentially that we're going to be working with in Mathematica. The cool thing about Alt 4 is it gives you kind of this nice little header, and you could close it. So I can close certain elements here. You could do that here. Alt 4 is a nice one though to kind of give you basically, kind of almost chapter headings in your notebook. So Alt 4, I could close the cell, open the cell, hidden messages are revealed. If you would please do so, I would really appreciate it if you submit notebooks all open instead of closed. But if I wanted to open all of the cells, all I have to go to is, I could just kind of highlight all my notebook, and I could go to cell, and I could go to grouping, and I could go to open all subgroups, and then boom, it's open. Hidden messages revealed. So again, Mathematica is meant, again, it's just a tool. And again, we want to make sure that we are coding and kind of working in this and treating this as a tool to solve our problems efficiently, effectively, and making sure we're productive with our work. So that's kind of the key idea here. So line by line evaluation, that is the critical thing in Mathematica. So let's start off with one of our best mathematical functions, 1 plus 1, and then I'm going to do Shift Enter. So you can see here, this is my input, this is my output, and we're good to go. We could do some more complex, so 5 times 5. Oops. Actually, that's a cool feature. So this takes the output from the immediate cell. So watch this. If I do this, and if I do this, it's 20. So it just takes the preceding line. I could just do this over and over again, and it's just going to continue to evaluate and evaluate and evaluate and evaluate. So that's a pretty little cool feature if you do that. But I want to do 5 times 2. I've got this. I could do 5 to the 4th. I could do that. I could do square root of 187. I can do and I could look at this numerically, so I could just do backslash n, and then I could also just multiply 5. I could do cosine of 90 degree as well, as opposed to cosine of 1, because that's going to be radians, and I could look at this numerically as well. So this is just your first example of line by line coding in Mathematica. Now, I am not the best person when it comes to commenting my code, but I do a much better job of it in this class. But it's a really, really, really good habit to do this. So you really have to kind of get started on learning how to comment the code. So let's go ahead and we'll jump into commenting right now. So let's go ahead and start to comment in Mathematica. So let's do our old friend 1 plus 1, and then we could comment simply by doing. So our commenting goes here and here, and the beautiful part, if you just notice that, let's do it one more time. In Mathematica 13, it completes that for, oops, let me do this one more time. So Mathematica 13, it completes it for you. So now I could just type, yep, this is still too, always fun. But again, so you evaluate it. Again, it doesn't evaluate the text, so it keeps it here. So we could do the same thing here. So this is for square root. Let's do square root of 157, and let's go backslash n. So for example, if we don't do backslash n, you just get this. If you do backslash n, so we could actually, so you could say that backslash n gives the numerical result. You could also do the same function, square root, and you're starting to see the syntax of Mathematica, right? So square root, if I just do lowercase, it matters that we have uppercase in Mathematica and that we're doing this. And the square bracket denotes we're starting to utilize a function. Basically brackets like this, your open print, your usual parentheses, that just indicates order of operations. This usually indicates a list. So this will give us an error if we do that. Actually, it won't give us an error, but it'll just put it in a little list there. So n square root, and then whatever my value is, let's do 157 again, so we could show here, and then again I could comment this basically, and at the front gives the same result, but backslash n at the end is pretty convenient. Excellent. So these are all numerical line-by-line calculations. You type it, you do Shift Enter, and you get a value. But this is not the most useful type of coding that we're going to be doing, because we want to be able to assign variables in Mathematica. So assigning variables in Mathematica is very, very, very simple and straightforward, as opposed to assigning variables in MATLAB or other conditions. So let's just say a equals 7, and that's going to be, so right now we can see new variables are blue right now, but when I evaluate, it will turn black. So let's see how that works. So now when I type a, it gives me 7. So I could do a times 10, that should be 70. I can do a cubed, I could do a minus 7, I could do all types. I could do square, a to the a. I could do all types of mathematical operations. I could do log of a, that's natural log. Again, I could do backslash n. I could do exponential of a. I can do log 10, or actually do log 10 of a. All types of good stuff. So But let's say I wanted to clear that variable. I could just also do b equals cosine of none. So I could do that. So you could have that value. If I want to clear the value, I can now clear a, and you see now it turned blue. And then now, when I do it, I get a back. So if I want to reevaluate it again, and I could do this basically, this function basically hides the output of our function. And then again, I could do a squared, and I could get the same result as last time. So 49, all those good things. So that's essentially how you assign variables in Mathematica. And you can assign variables to be, again, if let's say I say now it's 76, it's a squared, it's going to be this. So once you redefine it, again, the order in which you basically evaluate these functions is really critically important. Because once you redefine it, and this is why you need to make sure quit the kernel clears every variable. So the order in which you evaluate these things makes a huge difference. So just be aware and available for that. So next time, we're going to look at equalities, functions, lists, rules and replacements, and all other kind of cool stuff. So I will see you all next time. Thanks. Bye.